Yeah. All right, so this first one is a fairly typical viscosity. It looks like we're putting in chromium. So a chromium middle of the road viscosity. So this one should be green, but the chromium has an interesting property. It's called a variable striking of the color. It starts off brown, and then after it cools down past around 500 or 600 degrees, it then turns green. So that has to do with it settling into its position between a certain number of oxygens that make it transition from one color to the other. So got a hole in my glove, so hopefully it won't burn me through. All right, so we're starting with the front left. So go ahead. All right, so you go ahead and start heating the glass. And hit heat right out of the bead. It's going from the crucible right on top of the glass. There you go. Now get a little closer. Here we go. Now heat that spot right on top and try to get that to melt down in it. Just keep heating that until it scoops. That's good. So then get ready with those and go ahead and press it at the bottom edge. There we go. Okay. All right, so keep your eye on that. Get you?
Yes.
But you definitely can feel the heat coming out of there, right? Some radiant heat. So it starts off kind of brown, but then we'll transition to green. This one does have a bit of a bubble defect in the back, but sometimes that makes a stress field. So that one could shatter in about 20 minutes. Probably not. It might. We'll see. The ones I'm pretty sure that are going to shatter, I put a beaker on eventually. That one, it's kind of iffy. But here you can see on this top edge the brown color that eventually will be turning green. So, green on the bottom. Yeah, it's a little bit cooler on this piece. That top part is still brown. It's called the striking. What temperature does the color strike? That's the question. All right. So next up, we've got B, and that is slightly higher, right? Slightly higher on flux ranges. So we would expect slightly easier to pour, but pretty much the same. And this one has a medium load of copper, or of iron. And iron makes it amber or green. So, all right, let's do this. Go just a little faster, slow down right in the middle. Just kind of fast, slow, faster and slow. All right, I'm going to try to get that to melt back down in. Those gloves might help. You can still actuate the button. Yeah, it's intense. Usually it doesn't truly give you like second-degree burn. When you start feeling kind of toasted, especially cobalt glass, that stuff, the metal, it's such a dark glass, it absorbs so much heat and radiates it back out. That stuff is, the darker the glass, the hotter it will feel like that. All right, so that's looking good. Some of these won't have an obvious color until I bring in a little light table, and then we'll get some light behind it, and then you'll be able to see the color a little better. All right, so composition C. This one, So if you guys get creative, so we've got a slightly high sodium flux. To pour a little easier, should make a even slightly bigger disc because the flux makes it pour easier, lower viscosity. That will scale with the size of the disc that results. And then we added 0.7 copper, 5 grams of iron oxide, and 0.5 of manganese. So that's kind of a blue, light greenish, purple. I don't know what that's going to do. It's an experiment. So we'll pour that one right here. And try not to get you toasted by the crucible stabs behind. So, pulling from center. Alright. Always watching out for cracked crucibles, it makes a huge mess. Alright, that one has a bubble too, okay. So work the bubble with the heat. Now work the bead of glass through the crucible. Later on, there was some questions about viscosity. The lower the viscosity, the thinner that bead of glass is. Right. And also, make sure you're keeping in mind the back of the tank. I've never had one of those explode. That would be exciting. Don't get it too close to the crucible. It's probably not going to happen. That's what cool is. Once that cools down, it's pretty awesome. Definitely not a good day to wear flip-flops for that. And maybe put them down lower and then start putting the crucible down here. It's fiberglass that has some kind of a binder. I don't know what the binder is, but it makes it fire resistant. This is a Kevlar line, so I feel like a race car driver or an astronaut right now. It's so cool. Actually, people just usually make fun of me and tell me I look like Lady Gaga or something, or I'm in one of her videos. So, but I know they're just telling me that I'm with the times. It's cool. All right, D. This one is a little bit high on the calcium flux. So we're switching from high sodium, high calcium flux. And this one has a fairly high load of manganese. So this one will probably eventually be purple. So we'll pour that one right here. I can smell something, I guess the coating burning off of the fire-resistant glass mat there. So that's glass. Yes. So that's probably a good time to tell you what's going on there. The ceramic shrinks at a different rate than the glass. So you probably heard of coefficient of thermal expansion. Because those are welded together, that tension that's formed results in breakage of the glass. This is a process called crazing. And every time you hear that little tink sound, if you watch the glass, you'll see a new crack forming. Like right here, watch those crazes form on that glass. And so it's differential shrinkage. And eventually that'll be just a constant chorus with all these crucibles breaking glass. But since it's stuck, it doesn't actually shatter, it just makes a crack. What great. I'm holding the heat, right? Okay. Definitely see the purple color developing in that fiberglass forms. I'd say that the biggest hazard besides temperature hazard is the fiberglass. So try to resist the urge to pick that up and feel it, because what happens is it will break and then spring and stick into your finger. It can be nasty, especially if it breaks off inside of your finger, which has happened, not to me, not to my students, but before my time, someone did have a piece get broke off in their finger and had to get cut out by a surgeon. Really exciting. So we'll avoid that, hopefully. Also, when you're doing the torch, try to aim it so that you keep a minimum amount on the previous row. You can still project this way, but what happens is sometimes you can get a little too much heat here and it makes a hot spot that shatters the previous glass. So just kind of try to aim it that way. All right, next up, this one is low on the sodium and a little high on the calcium. So this one I'm thinking is probably going to be a bit more viscous. We'll pour that one right here. Colorant on that one is blue. So we've got 0.02 cobalt and iron. Cobalt, iron. I think the blue will take over, but it might tilt it a little bit purplish, blue-green. I don't know. We'll see. These are some new combinations we've never tried. So. And pulling from right. That was weird. Try it again. It seems like something's going to decouple there. Okay. It's a counterbalance system, so obviously something is loose inside. So notice how much thicker this is. Low sodium, high calcium. So it is mostly blue, but there is a bit of it's tilting the color. It's tilting it a little bit more green. So. All right, and like we predicted, notice the disc is smaller. A little less recovery from the crucible because it was thicker. What's that?
How much glass left in?
We could quantify that by weighing the disc and comparing it to the load weight. My guess is that we're always getting out a little over or under half to maybe 60%, but it definitely does disperse on the walls, and you're not getting all of it. These crucibles, in theory, can be reused a few times for similar batches, but when we're trying these experimental color batches, it makes it more difficult. All right, we're on S. So this one is super high on calcium carbonate. Probably higher than we've ever done. It's exciting. So it's standard sodium, really high calcium. So it's probably going to be a freer flowing glass. It might be brittle, so this one might shatter eventually. Maybe not. I think we'll be okay, and we'll see. And we've got 0.6 manganese and 0.05 nickel. So a smoky purple, I think, is what this will end up looking like. So right there, in the center. Okay. 9F. That's pouring really easy. That's because of the extra high flux load. See how that just came shooting out?
Yeah.
So low viscosity glass. Of course, viscosity always scales with temperature. So you could take a high viscosity glass at 1150, heat it up to 1300 and make a low viscosity glass. But we're comparing all these at a standard pouring temperature of around 1150 and then benchmarking viscosity. But you can always take a higher or lower pour temperature and get whatever viscosity you want. That's definitely the lowest viscosity so far. Take a look at that. That's a much larger disc. So higher recovery from the crucible, lower viscosity. It might be smoky purple. We'll see. Yeah, those stamps look nice and uniform. Good job. Now for G.
Going to give us a 10.
It's a little low on sodium, a little higher on calcium. I think that effect's going to average out, and we'll probably end up with a fairly standard size disc. And our loading color is a chrome iron. So high chrome medium irons. This is going to be super dark and hot. I think it'll be something in the green spectrum eventually. So we'll pour that guy right here. Run out of real estate. We might have to put a row over here eventually, but I'll try to keep them tight now. So we'll go here. Coming from back left. Yep. All right. So after we get rolling, I'll also clean up the crucibles so you'll be able to safely pick them up. If the fiberglass has to get broke off the outside before we do that. We're good. Little hot clear there. Slap shot. All right, so we got 4 more. This one's pretty typical, but slightly low on sodium, so slightly more viscous. And we've got a medium loading of chrome. This one's going to be pretty similar to A. It'll be a slightly lighter color, so you'll be able to see more a lighter color than an A. So we'll be able to compare those two. So we'll pour that one right there on the grid. H, 9H. Yeah, that's right. You will notice my lungs will start smoking here as I get deeper and deeper into the furnace. It's more exciting.
Turn to the up. Turn you turn on the up. How long do it take?
Guess what time I started?
Yeah.
Definitely work that. That's a free. Work that in, get the nothing. So.
Yeah.
Exactly. Yeah. So anything that shoots over here, just stick it underneath. I'm going to sweep up at the end. As far as the firing went, okay, we're setting up for I. I started the furnace at 5:40 p.m. yesterday, 23 degrees Celsius. I did set up the camera. Actually, I did come through here late last night as well. Around 11:14, it was at 928. So we were ramping from 5, around 6, between 6 and 11, we were almost there, up to 928. And then it sort of plateaus off and approaches that asymptote of 1150 more slowly. So then it probably reached that after another 4 or 5 hours. It's, the last 100 degrees, it just inches up to it. But you normally want it to sit at temperature for long enough to get all the bubbles to pop. You saw in my preliminary discussion, we're creating carbon dioxide in this process. Well, that makes bubbles in the glass. So the process of letting it stay at temperature is called fining the glass. Fining the glass. How long does it stay in the furnace? It has to be long enough to fine the glass. They'll talk about that next week. Which compared to this is a little crucible. The furnace in there is bigger than this room. Raging inferno. You get to look at that. You actually get to stand there and look at it through a little panel of basically welder's glass. So that'll be fun. I've never seen anybody catch themselves on fire, but it sure does look like you're about to. All right. So 9I is a little bit high on sodium, way low on calcium. Okay, so half. Whoa. So that actually is 0.5. There might be a decimal error on this. If it is 0.5 and not 0.05, this is going to be extreme cobalt glass. It's going to be black, essentially. So we'll see. Was there a decimal error on the writing, or was there a decimal error on the weighing?
I'm pretty sure it was the weighing.
So you put in 0.5 gram?
I don't remember, but I'm pretty sure it must have.
That's a lot of cobalt. So cobalt is super potent. So this is going to be this angry orange liquid when it's being poured. It's going to be super hot and radiant, and then it's going to turn so black that we're not even going to be able to look through it. But the fiberglass, we'll be able to see it's blue, but it's going to be a black glass. And from center. Okay. So let's see if it's true. Slightly viscous, dark black glass. All right, hit the. Yeah, that's.
Oh, look at that blue.
Yeah, that's beautiful. So you flamed out. That's pretty crazy. You flamed out on the. You flamed. Yeah, the torch then was igniting off the surface, and we had lost prime on the torch itself. So super dark. So if you wanted to make blue fiberglass, trying to get to that big ball stick right there. Yeah, I would snap the similar up in there. What's your right there? Slightly safer now. Okay, how lucky do I feel? I don't want to pour it off the edge there, so why don't we put a row on this. So all the heat that's being absorbed by this iron, yeah, 3 more. It would be enough to cook. I could fry an egg on this right now. So this is at a nice skillet temperature. So don't lean on it.
You said 3?
Maybe there's only 2 more. Yeah, there's only 11 in this class. So we'll put those, we'll still put them there. And yeah. This next to last one is pretty much standard load of flux and 27 on the green. It's really close to H. So H and J are going to be really close to each other. Yeah, they're from the same family. They're cousins. So we'll pour that one right there. All the way into the back. Gotta catch myself on fire. These last 2, the ones. It's like just drill. There you go. Okay, one more. This one is kind of a high sodium, high calcium, but not extremely high. Well, yeah, these are upper range. So this is pretty high. And then this one is that just chroma here? You guys are stuck on chroma. So we're going to have a whole range of green glass and slightly different decks, color decks. So that's fine. Green's cool. So we'll put that one right there. All right, that's cool. Yeah. Yeah, at the beginning you're like, oh, I can do this. And then you get about 2 or 3 in, and you're like, oh, about that. So it's all right. Yeah, this is nice when I do it in the. When I do this one in the spring semester, it gets nice and toasty in here. And it feels good because it's snowing outside. But I don't know. I'm not thoroughly enjoying the layered effect right now. Okay, so what I'm going to do now is I'm going to put on 2 5-minute videos. One shows art glass, the other one shows industrial side of glass. You probably have about a half hour, so I'll move these over to a light table at about 11:35, 11:40. But I'll put those on. They're kind of interesting. Get to see some different perspectives on glasses. So thank you for your help. But I'd say go on back and work on the crystals, and I'll put those videos on, and then I'll let you know when it's safe to handle the glass.